Hello, today we're going to briefly talk about how to create a Raspberry Pi hat. So it's essentially a device that goes on top of the Raspberry Pi and extends the functionality of the Raspberry Pi in some way, whether it's adding a sensor or controlling a motor or something like that. So the first thing you want to do is you need to get the Pi hat template. Now what this does is this is going to reduce your development time a lot because it's already got all the power and everything in it um, that is needed to run the Raspberry Pi. So the first thing you want to do is you want to clone this repo. You can also just download it as a zip. I've already done that, and you can download it here. And I've opened the project in KiCad. So you may need to correct the libraries, but they should probably be okay, especially if you're just using a standard KiCad install. So the first thing we want to do is we want to open up the schematic. So what you can see in the schematic is we have the Raspberry Pi connection, which has an additional sheet here, which is just for back power protection. This is recommended by the Raspberry Pi Foundation. So that's what we use on this board. It's an inexpensive circuit, so this is the Raspberry Pi main connector. It's got all the GPIO labeled. Then we also have the EEPROM as well, which can be used for device ID and other device information. For power management, we have a 5 volt DC to DC, 2.1 amps. It can take about 35 volts in. Then there's also an LDO that gives you 1.5 amps on 3.3 volts. And these are going to be very useful. This one here powers the Raspberry Pi, and this one here is meant to power your devices as well, depending on what you put on. So for today's example, we're going to make a Raspberry Pi hat that can read a thermocouple. So the first thing we want to do is we want to find the sensor we want to place. In this case, we are going to use one of these Max chips. There are many of them out there. The first thing we need here is we need a connector. This is where you might connect the thermocouple externally. This is actually supposed to be a special type of connector, but today we're just going to use something a little more standard. The next is we want ground and VCC connected. So ground we're just going to pull from anywhere. It's a common digital ground on this board. And then VCC, what we want to do is we want to pull that here from 3.3 volts. This LDO can actually be changed. This has nothing to do with the Raspberry Pi, so if you want a different voltage here, you can actually just change these two resistors, and that information can be found in the LM1117 datasheet. So the next thing we want to do is we want to connect the data bus to the Raspberry Pi, and in this case it's SPI, but it's only 3-wire, which means that you can only communicate, you can only read the device, you can't write to the device. So we're going to call this Pi slave out, call this Pi clock, and we're going to call this Pi chip select. And we're going to copy these, we're going to bring them over here. We're going to mirror them. Now these we want to make sure we put them in the correct location. So chip select can go on any GPIO, but in this case we'll just put it on the system chip select. SO is going to master in because it's the slave out of the device, and then the clock is going out of the clock. So there we have it. That's the device basically wired up. The next thing we want to do is we also want to add a quick decoupling capacitor. And the reason we want to add this is just because we are working with a pretty heavy DC to DC circuit, and there might be a ton of noise depending on what your layout looks like. The next thing we're going to do is we're going to quickly also add an LED. This is great just for visualizing that your program is actually working. It's really nice. And we'll just put it with the resistor. I'm not going to put values or part numbers to these ones. These are pretty standard, and I'm sure you can pick these ones out yourself. And we're going to tie this to a net, which we're just going to call LED. We're going to do the same thing. We're going to copy that net, and we're going to bring it over here. You can just put this wherever you want. It doesn't matter at all. So there we have it. That is the addition that we're making right now. So the first thing we want to do is we want to annotate it. One of the very important things about this is when you annotate the schematic is you do not want to clear the annotation. That's going to screw up everything that's already created in the template. Now what you want to do is you just want to make sure that you keep the existing annotation, which is set here. You don't want to reset it. This is the default setting for KiCad, so it shouldn't be a problem. The next thing we're going to do is we have to link the components to these actual parts. This is done using the CVPCB utility, and that's where it links the library footprint here to the actual footprint that we're going to be using on the PCB. A lot of the libraries it uses are in KiCad, or sorry, in GitHub, so it takes a second to pull those, so don't fear. It looks like KiCad's frozen, but it's not. You can answer yes to this. This is complaining about a legacy thing for this part down here. So the first thing we want to do is we want to choose what components we're using, and if you've used KiCad before, this is going to be very familiar to you. So I'm just going to fly through it. You only want to change all of the empty ones because those are what we added. I'm going to use 402s in this case for this connector. I'm just going to use a 2-pin screw terminal, even though for thermocouples that's usually not a great way to do it. And a 603 for the LED, and finally for this capacitor, and a 402 as well. So that's everything. Usually you'll have a lot more components, but that's pretty easy to expand upon. Then we want to export the netlist. We want to generate it. It's going to ask where we want to save it. The default directory is fine. Then what we want to do is we want to go and we want to open up KiCad PCB. Now what you'll see is that there's already a lot of stuff on here. Now that's everything that was existing in the schematic. So that's here. You can see the Raspberry Pi connector. This is the backpowering protection as well as an LED. And then we also have the EEPROM shoved in the corner over here with a jumper. And then all of the power circuitry. So this stuff you generally want to leave alone just because the way it is already working. If you do need to move it for your layout, that's perfectly fine. Just make sure that you check your routing when you're done. So we want to read our netlist. And what you're going to notice is all our new components have popped up here. We're going to place these quickly one at a time. So we're going to stick this guy here. We're going to put him right here. This is the decoupling capacitor, which we're going to put just close by. This is our LED. We're just going to put him in the middle of nowhere. And his resistor. So the next thing we want to do is we want to route it. Now this board comes with a number of default track thicknesses. We're going to use 0.3 in this case. We're going to quickly route this. So now we're going to tie the LED up into the Raspberry Pi connector. You can see that the net has changed. The next thing to do is going to be to tie in the SPI as well. And that's very easy. Again, this is not the correct way to set up a thermocouple, but for this example it works. So the next important thing, and it's the last step we have to do, is we have to tie this into our power. So to do that, you can see that the 3.3 volt net is highlighted all the way around. And now the best place to get the power from is right here. That is right off of the terminal on the LDO. So what we're going to do is we're going to put a via, it's a pretty big via, and we're just going to head right into there. Now you can also see that there's a 3.3 volt net here, which is used for the LED up there. It's much thinner, and you're not going to be able to pull too much current off of it. For this device it would be fine, but if you are pulling more than a few milliamps, you want to use larger traces, like if, for example, you're powering a high-powered LED. In that case, you would want to do that. So anyway, that is our design, and we can go and take a quick look at that in 3D. There you go, pretty simple. Yeah, so that's how you make a Raspberry Pi hat in not a lot of short amount of time. Most of these components can all be populated by hand. I've done it a couple times. The 402s they are pretty small, but if you're used to it, it's not very difficult. Just make sure that you do the through-hole components at the very end. The EEPROM is not necessarily required, but it is good if you're developing software because it allows the Raspberry Pi to identify what hat is actually being used. But if this is just your own application, you don't need the EEPROM at all. The back powering, I do recommend putting that in, even though it can be skipped over. yeah, so thank you very much for watching.